In this video, we're going to learn how to display and work with the debugger. You use the debugger to trace and check whether our programming meets functional expectations. It lets you check the status of the memory, the value of the variables, the current records and selections of each table, and the code running it while tracing. We're going to reuse the form with the variables to explore the debugger. We'll add a breakpoint, we'll come back to this later, and display the form. When we use buttons that are not within the trace mode, execution takes place normally. If we click on a button that is within the trace mode, the debugger appears. We can define 5 areas in the Explorer. First, the source code pane. This shows the method being executed. Here we can place and remove breakpoints, drag the yellow cursor indicating the next row to execute up or down so it's possible to go back to the code that was already executed, move the mouse over a field or variable to display its contents, click on an object and move it within the expression area. Second, the second area concerning navigation buttons, we'll cover it more thoroughly later on. A help tip explains what each button does. Third, the custom watch pane area here. Fourth, the watch pane contains all the expressions available in 4D, tables, fields, constants, variables, processes, and so on. Fifth, the call chain pane represents a chain of methods that let us get to the program displayed. We're going to stop the method execution. There are 5 ways to display the debugger deliberately. First, by inserting the trace command in a method. Whenever the trace command is found, the debugger is displayed automatically. Second, by placing a breakpoint. That's what we did on this button here. Third, while using the program during execution, you can use the following shortcuts: Alt, Shift, right-click on Windows, or Command, Alt, Control-click on Mac. The list of processes appears. For the moment, we're tracing in the main process. Later on, in the case of multi-process operation, you can choose which process to trace. So we chose the main process, and if we click on declarations, automatically the trace mode appears, and we can see the contents of the pop1 variable. We can enlarge the window of the trace mode. We can memorize the position and the variables stored there, and even change the values there directly. So if we want to change the value of v1, we can put 300 and here another version of the third phrase. Obviously, if we retrace the main process and we assign values to the array, when we go by here again, on the third row, we'll now have the value that was set there. As said before, it is possible to move the cursor back up in order to execute the rows again. Fourth, in the design environment, when you execute a method, you can click on the execution button and choose Run and Debug, either in the application process or in a new process. In this case, the trace mode appears automatically so that we can debug the method. And finally, one last way to show an equivalent to trace mode is to use the Runtime Explorer by pressing Ctrl-Shift-F9. The Runtime Explorer, which is only available to developers and other authorized users, lets you display the list of processes, for instance the main process, and then trace it. From here, when we click on a button that executes code, we'll see the trace mode appear with the line of code that is about to be run. So there are 5 ways in all to display the trace mode. The most frequent of these are breakpoints and keyboard shortcuts. The debugger also appears, usually unintentionally, when 4D cannot run your code, such as with syntax errors. It displays a message so that you can switch to tracing. Let's look at an example in the navigation method. If we remove the equal here and save, 4D displays an error and offers to trace the code in order to show us the problem.